In this section, we're going to talk about the logic problem on the UCS fabric interconnects with multiple upstream Ethernet networks that are not connected to each other, which they call disjoint layer 2. And we'll see why this is a problem to begin with that relates to the end host mode of the fabric interconnect and how the pinning decision is made, and how we can run into some situations where we're dropping traffic going down to the blade servers if it is coming in the wrong interface or if we don't have the correct VLANs provisioned. Now, first off, we want to know, what does this term mean? What is disjoint layer 2? It essentially means, from a physical design point of view, that we have the fabric interconnect. So let's say we have fabric interconnect A, and we're going up to two different physical switches. So we go to 5K1 and we go to 5K3. But between these switches, we do not have an east-west layer 2 link that is trunking between them. So in other words, we have isolated layer 2 networks. Like we have VLAN 10 on the left, we have VLAN 20 on the right, and then these are unrelated layer 2 domains. Okay, so it essentially means that not all trunk links are going to be carrying all VLANs. So as we go from the FI over to 5K1, we're carrying VLAN 10. As we go from the FI over to 5K3, we're carrying VLAN 20. But the issue is going to be that since the fabric interconnect is not running spanning tree by default, it's not going to be able to detect which MAC addresses actually exist where, because we're only learning MAC addresses on the southbound facing interfaces. So from the fabric interconnect southbound towards the I/O module and then towards the blade. So MAC addresses will be learned here, but MAC addresses will not be learned on the upstream interfaces. Okay, the reason that this is going to be a problem is the way that it has to do with the way that the UCS determines what link is going to be used for the reverse path forwarding check, and then also what interface is going to be used for the dedicated broadcast receiver. So before we talk about what the solution is to this, we need to see what is the problem and why is it a problem to begin with. So let's look at first a functional example where we have the two blades that are booted. We have two different VMware ESXi instances, so we're going to have two different management IPs. We're going to put these in two different subnets, two different VLANs, and then look at the connectivity from our end host over to these different subnets. Okay, so as it currently stands, we have Fabric Interconnect A has VNIC 0 that is going to chassis 1, slot number 4, and this is going towards 10.0.0.102/24 is the IP address that we have on the blade. Okay, we also have a server that is on chassis 1, slot 5. We're going to put this guy in VLAN 20. Okay, so let's say that this is 20.0.0.101/24. So this means that we're, from the UCS point of view, we need to create the new VLAN. We're going to assign the VLAN to the virtual NIC. Okay, so the VNIC that's going down to the OS. We're going to create the VLAN on the 5Ks, and then we're going to trunk the VLANs down to the fabric interconnects. Okay, so let's start at the 5Ks and then work southbound. So 5Ks, nothing really special about the config. Just in global config, we're going to create VLAN 20. If we look at the show spanning tree for VLAN 20, we should be forwarding this out the downstream facing interfaces. Okay, so port 9 and 10 are going to the fabric interconnect. Notice here that on port number 10, the interface is in blocking state, or more specifically, the VLAN is in blocking state from a spanning tree point of view. The reason why is that this interface is not configured as an edge port. So the switch is sending it the RSTP synchronization request, the proposal. The fabric interconnect is not responding because it's not running spanning tree. End result is that for backwards compatibility, we're going into legacy listening and learning, where port number 9, which was configured as an edge port, immediately goes to the forwarding state. This is the reason that you want to configure the links as edge trunk that are going towards the FIs. Okay, so we're going to do this on both sides. We'll say that on interface E1 9 to 10, this is a switch port. The switch port mode is trunk, and the spanning tree port type is edge trunk. Okay, so same thing on 5K2. Let's look at the show CLI history, unformatted, show me the last 20 lines. So we're creating VLAN 20, and then we're applying it to the ports. Okay, so same thing over here. Okay, we're now going to create interface VLAN 20. Okay, so interface VLAN 20, IP address will be 20.0.0. Let's say the 5K2 is going to be 52. and we'll run HSRP. So we'll have HSRP 20. Virtual address is going to be 20.0.0.254. No shot. Okay, same thing on the other side. On 5K1, we're going to create interface VLAN 20. IP address is 20.0.0.51. Then we have HSRP group number 20. The virtual IP is 20.0.0.254. Okay, now let's go down to the fabric interconnects, and we're going to need to create these VLANs. So we're going to go to the GUI. We're going to go under the LAN tab. And then under LAN, we're going to go to LAN Cloud. Then under VLANs, right-click, and we're going to create VLANs. Okay, so we'll say that we have just VLAN 20. Okay, will be the name. Okay, VLAN ID is 20. And then this is applied onto both fabrics. Okay, so VLAN 20 should automatically be trunking northbound. If we were to go to the Fabric Interconnects CLI and we look at the show interface trunk, we should see that we have two interfaces going northbound. So interfaces E13 and E14, and they're carrying VLANs 1, 10, and 20. So basically all of the VLANs that we have locally created. Okay, same should be true on Fabric B. So we go over to Fabric B. Let's log in. Then connect NXOS and show interface trunk. Okay, we have VLANs 10 and 20 forwarding on port number 3. Okay, so for the disjoint config, we're only going to look at this on Fabric A. It would be the same exact problem we would run onto Fabric B. You just need to do the configuration twice. So on Fabric A, we're going to have links that are going to, not two different switches in this case, but two different trunk links that are going to the same switch. Disjoint layer 2 could be going to one physical box or multiple physical boxes. It basically just means that the VLAN allowed list is not the same on the northbound network side as it is on the UCS side, and that's where we're going to run into trouble. Okay, so VLAN is created. Last step is that we're going to assign it down to the server. So let's go back to the UCS manager. We're going to then go under servers. We're going to go under service profile. So we're going to go to the first profile I had. Okay, profile number 1. We're going to go to the virtual NICs. Okay, so let's say vNIC ETH0. We're going to modify VLANs, and then we're going to remove VLAN 10, okay, which is the VMware management VLAN. We're going to move this to VLAN 20. So we're unchecking VLAN 10, and then VLAN 20 we're going to configure as native. Okay, this just means that from the VMware vSwitch point of view, we don't need to do VLAN tagging for the management port. We'll talk about later when we're dealing with the standard vSwitch for actual data plane, the DVS, and then the application virtual switch, the AVS for the API controller. But typically in most designs, you don't tag the management VLAN, you just leave that as native. And then anything that is data plane for the actual VMs, that's going to be a normal trunked VLAN. Okay, so it basically means that the hypervisor doesn't know it's in VLAN 20. It's just untagged traffic that's going southbound to the access layer. Okay, so we're going to do this on Fabric A and Fabric B for this profile. So this was under ETH0, okay, of this profile. So service profile is, it's actually Brian profile 1, but again, this is an issue with the rendering of the HTML5. So let me go back to a different screen, equipment, then back to servers, and then profile number 1. For whatever reason, it's not highlighting it, but if we go over to the right here, you can see the name is profile number 1. Okay, so then let's go to ETH1. So this is on chassis 1, slot 5, so blade 5, adapter number 1, and then host Ethernet interface 1. Okay, so we're creating multiple virtual adapters. So we're going to modify VLANs. We're going to check VLAN 20, uncheck the management VLAN, and notice that it changes to native. Okay, if you only have one VLAN on the link, then it has to be the native VLAN. If you want only one VLAN but you want to tag it, you would have to add the default, which is VLAN 1, and then set that to native. So this is essentially the allowed list going southbound to the OS, and then the right one here is just saying out of all of these possible VLANs, which one is native. Okay, so we're going to have VLAN 20 as native. Okay, then let's go to the KVM. So let's go back to the profile under General, then under KVM Console. And we need to configure the IP address in this subnet. Okay, so from the server, let's go into customize. So we hit F2. Okay, username is root, password CCIEDC01. Then F2 again, we're going to go to configure management network, IP configuration, and we're going to put this guy on the 20 network. So let's say 20.0.0.101/24. Gateway is 20.0.0.254. Okay, then escape should say, do you want to restart the management network? Yes. Okay, so from the local machine, the local machine's gateway is 10.0.0.254, which is the HSRP address of the 5Ks. This should allow us to route into the 20 network, which is also directly connected on the 5Ks. Okay, which we can reach. And then we should be able to reach the server itself, which is 20.0.0.101. Okay, both of them we're able to reach. Okay, so the other hypervisor is going to be 10.0.0.102. Okay, so as it stands now, no connectivity issues. They're in two different VLANs. They have two separate default gateways, and then the 5Ks are routing the traffic between the segments. Okay, now let's look at when we have different allowed lists from the 5K point of view back down to the Fabric Interconnect. Okay, so we're going to go to 5K1, and we're going to say that the first port going to the FI, so let's look at the show LLDP neighbors. First port, which is number 9 from their point of view, I'm going to trunk only VLAN 10 on this link. And then the second port, I'm going to trunk only VLAN 20. So let's go to E19, and we'll say the switch port trunk allowed VLAN list is number 10. And then on E110, the allowed VLAN list is number 20. So if we look at the show spanning tree for VLAN 10, show spanning tree for VLAN 20, we should see that 9 is forwarding only 10, 10 is forwarding only 20. Okay, so pretty straightforward from the 5K point of view. Nothing really tricky about the config. Okay, now we go to the UCS, and what I want to know from the CLI is what are the virtual Ethernet interfaces, the specific numbers that were spawned that correspond to the VNICs of these individual servers. So we saw that from the GUI, we could go to the physical server, go to the VIF paths, the virtual interface paths, then it's going to show us the virtual circuit number. Or from the CLI, we can simply look at the show interface, and we're going to pipe to include vEth or server. And then this is going to tell us what the mappings are. Okay, so vEth number 698, this is server number 5. vEth 702, this is server number 4. The next thing I want to know is what is the pinning for these two interfaces. Okay, and again, there's two ways that we can check this. We can look at either the show pinning border interfaces, the show pinning server interfaces. It's ultimately going to show us the same information, just in a different format. Okay, also technically, third option, we can say show pinning interface vEth 698 or show pinning interface vEth 702. So let's look at the show pinning for the border interfaces. It says there's two border interfaces. There's E13 and there's E14. Okay, the first virtual Ethernet 698 got pinned to the first link. The second virtual Ethernet got pinned to the second link. So what the system is trying to do is a very basic load balancing just based on round robin. It's not based on a per flow or a per packet load balancing. It's just saying per server, server number 5 is going this way, server number 4 is going that way. We're not accounting for whether server 5 has more I/O on the network than server 4 does. It's just a very, very basic load balancing decision. Now, the issue is going to be, though, that if we look at the show interface vEth 698, this is the interface that we're trunking VLAN 20 on. Actually, let's say show interface vEth 698 trunk. Okay, same as just saying show interface trunk. It says that we have allowed VLAN 20. And then if we look at on vEth 702, we should be allowing VLAN 10. Okay, so let's look at this visually, specifically what's going on. So 5K1 is saying that 10 is allowed to go this direction and 20 is allowed to go that way. Okay, we're talking about the different VLANs. But from the UCS point of view, we had vEth 698, which was pinned to E13, and then we have VETH 702, I think it was. Yeah, 702, which is pinned to E14. VETH 702 is the one that we have trunking VLAN 10. VETH 698 is the one that we have trunking VLAN 20. Now, from the 5K's point of view, the issue is going to be that when a packet comes up in this direction and it's tagged as 20, since 20 is not in the allowed list, the traffic is going to get dropped. Okay, or likewise, a packet with VLAN 10 comes up this way, 10 is not allowed, so 10 is going to get dropped. But from the FI's point of view, since it's not running spanning tree and it's not exchanging the regular per VLAN BPDUs, it doesn't know what particular MAC address is located on what port northbound. The only thing it knows is what are the MAC addresses of the servers facing southbound, but not the other direction. Okay, so what this now means from a connectivity point of view is that we should not be able to reach either of the servers. Because the traffic is going to go up to the 5K. The 5K is now going to flood the traffic out whatever interface that it's running spanning tree on. Okay, so the subnet 10 is mapping to VLAN 10. This goes up to 5K1. 5K1 is going to say show spanning tree for VLAN 10. Port 19 is a designated port, so we're going to flood traffic out that direction. The destination MAC address gets received on the UCS. The UCS says show MAC address table for VLAN 10. We see the MAC address assigned to the virtual Ethernet. Okay, so that's going to be the management IP of the ESXi machine. But the issue is that when we look at the show pinning for interface VETH 702, the UCS is expecting the traffic to come in on port E14. And this is the reverse path forwarding check. That it's saying not only when we go from southbound to northbound are we going to exit out this interface, so any traffic received in on VETH 702 is statically routed, essentially, statically switched out physical interface E14, but it also means that the reverse is also true. If a packet comes in any other interface besides E14 and it's trying to go down to VETH 702, so it's going to either of these particular MAC addresses, if it doesn't come in this link, it fails the reverse path forwarding check, and the end result is that the packet is lost. And we can see this is the case because if we go up to 5K1 and we ping 20.0.0.101, and we ping 10.0.0.102, we see that we have partial reachability. Now for the first server, or the server in VLAN 20, the 20.0.0.101, it just so happens that the pinning is going in the correct direction. But since it's a dynamic decision, we don't necessarily know which one is it going to choose. Is it going to choose the first interface or is it going to choose the second one? It also depends on failure order and the failure recovery. Okay, so let's say from the Fabric Interconnect point of view, we look at the show pinning for the border interfaces again. We see that the first interface is used for 698, second interface is used for 702. If the first interface physically fails, so we go to the 5K, we shut the port down, the UCS is going to realize this and it's going to repin the VETHs. So now Ethernet 1.3 is down. It means that everything that was bound to that now needs to move over to E14. What this should now mean is that the reverse path is correct for the VLAN 10 traffic. Okay, so VLAN 20 we're able to reach, VLAN 10 not able to reach. Okay, so let's try this the other way. Let's actually go to E19 and we will no shut, and then E110 we will shut. Okay, this should be the correct order. So we ping 10.0.0.102. Now we're able to reach that server in VLAN 10. We go to reach the server in VLAN 20. Okay, let's see which direction we actually are going. Let's look at the show IP ARP. And this is going towards this address. Okay, so it's the same MAC address. Let's look at the show MAC address table for that address. This is going across E13 to the other switch. Okay, what this actually means is that the FI is pinning the traffic the wrong way. The one that's coming from 698 is actually going that way. So what I can do to fix this, I just need to go to the VMware splash screen. or the VMware console, and I need to change which adapter it's using for management. So I'm going to go to Network Adapters, and I'm going to change this to vMNIC1. Okay, this is basically running into the same problem that we saw previously with the vNIC VHBA placement policy, where vNIC0 is mapping to vMNIC1. vMNIC1 is mapping to, and the other way around. So vMNIC0 maps to vNIC1, vNIC0 maps to vMNIC1. Okay, it's essentially backwards. But I can change this from the OS point of view just by telling it to use the other adapter for management. So the end result of this should now be that 5K1 goes to send the packets to VLAN 20, and they get black holed. Because from 5K1's point of view, if we look at the show spanning tree for VLAN 20, the southbound interface is no longer up. Okay, so let's say interface E1 9 to 10, both of these are up. E1 9 to 10, no shut. Okay, now let's show spanning tree for VLAN 10, show spanning tree for VLAN 20. Okay, they're forwarding on ports 9 and 10 respectively. Okay, we now ping to 10.0.0.102. We're able to reach it. Let's ping 20.0.0.101. Not able to reach it. So you'll see that the result of this is non-deterministic, or basically you can't predict which direction the UCS is going to choose. It's based on the order that the vNICs come up, or essentially based on their numbering scheme. That server 5 was booted before server 4 was, or if it was associated first. So it's getting the lower number of the vETHs. It's just starting at whatever the lowest number port is and then working down from there. So if we go back to the FI and look at the show pinning for the border interfaces, we should see that now the traffic gets redistributed to the first link. The reason why is that the second link was down. When the second link came back up, the interfaces were not redistributed equally between the two of them. So the key here is that it's not doing load balancing between the two interfaces. We can only pin to one direction at a time. So if one of the interfaces are up, then half of the traffic is being lost. Okay, if we flip this around, if we shut down port number 10, the end result should be that we should regain connectivity to one of the servers, but not to the second one. Okay, or vice versa. We go to E19, shut that down. We go to E110, no shut. Ping both of the servers. Now 20.101 should work. Okay, let's see which direction VLAN 20 is forwarding. Show spanning tree for VLAN 20. We're going on E110. If we show LLDP neighbors, E110 is going to E14 on the other side. So if we go to the Fabric Interconnect A, look at the show pinning for the border interfaces. These are both pinning to VE702, or excuse me, they're both pinning to E14. So I should be able to hit this destination. Let's try clearing the MAC address table. Clear IP ARP actually, and then ARP again. Okay, let's try shutting it down. Interface VLAN 20 shut. No shut. Ping 20.0.0.101. Okay, so it had the old stale ARP entry, which is pointing to the wrong MAC address. So it should be still one or the other. So basically the problem is that we can't gain connectivity to both of them at the same time because the UCS doesn't know which VLAN is being pinned to which particular interface. Now there's a couple different simple solutions for this. The simplest solution is just don't have disjoint layer 2. If you have multiple northbound interfaces physically, you would simply channel them together, trunk all VLANs on the same link, and then you never run into this problem. But the reason that this is a design issue to begin with usually has to do with some sort of compliance, like PCI compliance or HIPAA compliance, depending on what individual market that you're dealing with, like financials, healthcare, et cetera. You might run into a situation where you're required that certain types of data are not allowed to transit like the DMZ switch or it has to go on a separate physical network, so there's a physical air gap as opposed to a logical VLAN separation, and UCS by default won't be able to deal with that. Okay, so if I was to go to the 5 case and just trunk both VLANs both directions, this would never be an issue. Okay, or if we think about this from a larger design point of view,